2023 National Electrical Code doesn't explicitly limit the bonding of the grounded conductor and the ground electrode conductor to a single instance, excluding exception. This is a common point of misunderstanding in electrical installations. It's crucial to consult the specific sections of Article 250 of the NEC to ensure proper grounding and bonding practices are followed. Let's delve deeper into the concepts. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices like circuit breakers to trip and clear the fault. Bonding ensures that all metallic parts of an electrical system are at the same potential, minimizing the risk of electric shock. The grounded conductor, often referred to as the neutral, is intentionally connected to ground at the service equipment. This connection establishes a reference point for the electrical system and helps to stabilize voltage. The ground electrode conductor connects the grounding electrode system to the grounded conductor at the service equipment or separately derived system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The purpose of the grounding electrode system is to provide a low impedance path to earth for fault current. Now let's consider some specific scenarios where multiple bonding connections might be encountered. In separately derived systems, such as generators or transformers, the grounded conductor is required to be bonded to the system grounding electrode at the source of the separately derived system. This ensures that the separately derived system has its own dedicated ground reference. In some cases, supplemental grounding electrodes may be installed to improve the effectiveness of the grounding system. These supplemental electrodes are typically bonded to the main grounding electrode conductor. It is important to ensure that all bonding connections are made in accordance with the NEC requirements. Improper bonding can create impedance in the grounding path, which can increase the risk of electric shock. When installing grounding and bonding systems, you should follow these guidelines. Firstly, use the correct size and type of conductor for the grounding electrode conductor and bonding jumpers. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Bonding jumpers must be sized according to the equipment grounding conductor requirements. Secondly, make sure that all connections are clean and tight. Loose or corroded connections can create impedance in the grounding path. Use appropriate connectors and tools to ensure proper connections. Thirdly, protect grounding electrode conductors and bonding jumpers from physical damage. Exposed conductors should be installed in conduit or otherwise protected from damage. Fourthly, avoid creating ground loops. Ground loops can occur when there are multiple paths for ground current to flow. This can create unwanted circulating currents and increase the risk of electrical noise. Fifthly, inspect grounding and bonding systems regularly. Check for loose connections, corrosion, and physical damage. Repair any problems immediately to maintain the integrity of the grounding system. Let's examine the role of the equipment grounding conductor. The equipment grounding conductor provides a low impedance path for fault current to return to the source from the non-current carrying metal parts of electrical equipment. This helps to protect against electric shock in the event of a fault. The equipment grounding conductor is typically a wire that is run along with the circuit conductors. It is connected to the metal enclosure of electrical equipment, such as appliances, motors, and panels. The equipment grounding conductor is also connected to the grounding electrode conductor at the service equipment or separately derived system. It's important to differentiate between the grounded conductor neutral and the equipment grounding conductor ground. The grounded conductor is intentionally connected to ground at the service equipment, while the equipment grounding conductor is connected to the non-current carrying metal parts of equipment. These are two distinct conductors with different functions. The NEC specifies requirements for the installation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electric shock by detecting small imbalances in current flow. When a GFCI detects a ground fault, it quickly interrupts the circuit, preventing electric shock. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Surge protective devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, utility switching, or other electrical disturbances. SPD divert the surge current to ground, preventing damage to sensitive electronic equipment. SPD are typically installed at the service entrance or at individual equipment locations. Article 250.6 defines the requirements for the effective grounding path. The path to ground from circuits, equipment, and metal enclosures must be permanent, continuous, and have adequate capacity to conduct safely any fault current likely to be imposed on it. Additionally, the impedance must be sufficiently low to limit the voltage to ground and to facilitate the operation of the circuit protective devices in the circuit. Article 250.4 contains general requirements for grounding and bonding. This section differentiates between grounded systems and ungrounded systems. Grounded systems are required to be grounded in accordance with the NEC, while ungrounded systems are not required to be grounded, but must still meet certain bonding requirements. Article 250.24 addresses grounding service supplied alternating current systems. For grounded systems, the grounding electrode conductor must be used to connect the grounded conductor to the grounding electrode. The grounding electrode can be a metal underground water pipe, a ground rod, a ground plate, or other approved electrode. Article 250.50 covers grounding electrode systems. All grounding electrodes that are present at each building or structure served must be bonded together to form the grounding electrode system. This ensures that all parts of the grounding system are at the same potential. Article 250.52 specifies the requirements for grounding electrodes. This section lists the types of electrodes that are permitted to be used for grounding, such as metal underground water pipes, metal building frames, ground rods, and ground plates. Article 250.64 outlines the requirements for the grounding electrode conductor installation. The grounding electrode conductor must be securely fastened to the surface on which it is carried. It must also be protected from physical damage. Article 250.66 provides guidance on sizing the grounding electrode conductor. The size of the grounding electrode conductor is based on the size of the service entrance conductors. Table 250.66 is used to determine the minimum size of the grounding electrode conductor. Article 250.68 covers connections to grounding electrodes. Connections to grounding electrodes must be made by exothermic welding, listed lugs, listed pressure connectors, or other approved means. The connections must be accessible for inspection and testing. Article 250.92 addresses bonding service equipment. The service equipment, such as the service disconnect and the meter enclosure, must be bonded together to ensure that all metal parts are at the same potential. Article 250.94 covers bonding for separately derived systems. Separately derived systems, such as generators and transformers, must be grounded and bonded in accordance with the NEC. A grounding electrode conductor must be used to connect the grounded conductor to a grounding electrode at the source of the separately derived system. Article 250.96 addresses bonding other enclosures. Metal enclosures containing electrical conductors must be bonded together to ensure that all metal parts are at the same potential. This includes enclosures for raceways, cables, and equipment. Article 250.102 provides requirements for bonding jumpers. Bonding jumpers are used to connect metal parts together to ensure that they are at the same potential. The size of the bonding jumper is based on the size of the equipment grounding conductor. Article 250.104 covers bonding of piping systems and exposed structural metal. Metal water piping systems and exposed structural metal that are likely to become energized must be bonded to the grounding system. This helps to prevent electric shock hazards. Article 250.118 lists permissible types of equipment grounding conductors. This includes wire type, cable type, and other approved means of providing a path to ground for fault current. Article 250.122 provides guidance on sizing equipment grounding conductors. The size of the equipment grounding conductor is based on the size of the overcurrent protection device in the circuit. Table 250.122 is used to determine the minimum size of the equipment grounding conductor. Article 250.130 covers equipment grounding conductor connections. Equipment grounding conductors must be connected to the grounding electrode conductor or to the grounded conductor, the service equipment, or separately derived system. They must also be connected to the metal enclosure of the equipment. Article 250.134 addresses equipment connected by cord and plug. Cord and plug connected equipment that is likely to become energized must be grounded. This is typically accomplished by using a 3-prong plug and receptacle. Article 250.146 covers the use of the neutral conductor for grounding equipment. In some cases, the neutral conductor can be used to ground equipment, but this is only permitted under certain conditions. Article 250.148 addresses continuity and attachment of equipment grounding conductors to boxes. Equipment grounding conductors must be connected to boxes in a manner that ensures a reliable electrical connection. This can be accomplished by using grounding screws, grounding clips, or other approved means. Remember to always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Electrical work should only be performed by qualified and licensed electricians. Improper grounding and bonding can create dangerous electrical hazards. Always prioritize safety when working with electrical systems.